Hello everyone. Today we are going to apply dimensionality reduction to coupon recommendation system to redact the dimensions of the data set. We usually use dimensionality reduction to um, avoid the computational complexity of the model and make it easier to visualize features of the data by preserving the important features of the data and leaving the rest. First, we have imported Streamlit, which is an web application which is used to create an interactive interface. Next, we have imported Mondas, um, which is an which is used to manipulate the data and used for data analysis basically. Next, we have imported a PCA, which is a principal component analysis from sklearn dot decomposition, which is main thing that we're going to use to reduce the dimensions of the data set. Next, we have imported t-distributed stochastic numeric embedding, which is also on another technique like PCA, which is used to reduce the dimensions of the data set. Next, I have imported a standard scalar. Um, Standard scalar is a preprocessing technique that can be used to convert the category values to numerical values, basically. Next, I have imported a matplotlib, which is a visualization library, as we all know, which is used to create interactive graphs, visualization, etc. So we have set the page title as a dimensional reduction app, and the layout is wide. Next, we are going to apply PCA to data to redact the dimensions, and from the number of components or number of features dimensions we redact. So standard scalar, it takes a mean as 0 and a standard deviation as 1. Next, the scale data is standard scale is applied to the original data to scale the data to numerical values. Next, the PCA is defined to the number of components we select, number of dimensions we want to redact. Next, the reduced data, the PCA is applied to the scale data to redact the dimensions of the scaled data and it is stored in a variable called reduced data. Next is the explained variance explains the difference between the original data and the PCA applied to the scale data, and it returns the reduced data and explained data. Next, it does the same for t-distributed stochastic numeric embedding, same functionality for reducing the dimension. Next, main function, we have set the title as a dimensionality reduction for coupon recommendation system. This is a file uploader. It ensures the user to upload file to the application. If it checks whether the file is uploaded and reads the file into and reads the data set into data frames. And the header, we have set the header as a data preview. It only reads the first few rows or 5 rows of the data. Okay, this part of the code checks if there is a numeric columns in the data set. If there is no numeric columns in the data set, it returns a warning as no numeric columns found in the data set. And, we have set the sidebar as a dimensional reduction, which is a sidebar dimensional reduction option. As we know, PC and TSNE, we can select which kind of dimensional reduction we are going to use. So number of components, like a number of components is about a number of dimensions we want to reduce. We can choose number of dimensions from minimum 2 to maximum 10. Next, the sidebar apply is if you select a PCA and number of components you want to reduce as 2 or 3. Um, it applies the PCA technique PCA, and it returns the explained variance and reduce that what is reduce the data of the data set. And if the technique is the same, and the technique is same for TSNE. Next, subheader reduce the features. It showcase the reduced features. What are the features we have reduced from the original data? If the component is 3, it shows like first component has reduced about 50% of the unwanted data, and the second column was reduced about 20%, and the third column is reduced about 30%, etc. So this is it. So let me show you the app. So this is the app. We have uploaded our coupon recommendation system data set, and you have chosen technique as PCA here, and number of components as 3. So we're going to apply this. So it showcases the applied explain variance, which is which is for the component 1. It is about 33%, and next 17%, next 14%. So this is the reduced features, component 1, 2, 3. So this is it. Thank you.